And welcome everybody to improve packaging efficiency with those new COF stable resin. My name is Timothy and I will be your host today. Our expert speaker will be Ms. Mei Yen, and Use Marketing Technical Manager for Southeast Asia, Australia and New Zealand from Dow Packaging and Specialty Plastics. Let me introduce the agenda for today. After this short introduction, we will have a brief video demonstration, a quick polling question to use so we could adjust our information, and then Ms. Mei Yen will provide her speech regarding improving packaging efficiency with Dow's new COF stable resin. After that, we would kindly ask you to answer our second polling question, and after that, we will have a long open forum where you are most welcome to ask any and all of your questions regarding this topic. This webinar by Dow Chemicals is an answer to a well-known issue of unstable coefficient of friction, COF, in lamination films, which is responsible for causing delays, film breakages, and overall lowering the efficiency of production line. Today, we will learn the following: challenges in managing COF in Southeast Asia, COF migration issues and how it affects downstream production processes, and we will learn about Dow's innovative new resin and how it allows converters to manage their COF. Our esteemed guest speaker today is Ms. Mei Yen, who, with 15 years of experience in the technical field of polyolefins, is the expert on sustainable packaging solutions. Now, I would like to quickly provide you a short information with how to use our platform and especially how to leave the questions for our expert for the open forum at the end of today's webinar. At the bottom of the right corner, you have the chat window, and there are two options. The green bubble allows you to write messages, and if you switch to the question mark, you will be asking the questions that will be marked by the system for the speaker to answer them during the open forum. Also, any sentence ended with a question mark will be marked as a question as well. For your convenience, you can also click the gear icon on the right side at the top of the chat and turn on the translation for your native language. That would translate automatically all of the messages in the chat into your language. How is it possible to chat between participants? We only have the public chat available, so I do hope that you can engage in discussions on our public chat. For the polling questions, you will see a screen like this. Please select the answer that you would like to, and then below you will have a submit vote button. Please don't forget to click on it. Now, for the open forum at the end of this webinar, we will have two experts from Dow Chemicals, Ms. Mei Yen, the End-Use Marketing Technical Manager and the expert speaker for today, and Ms. Annie Liao, the Technical Service and Development Scientist from North Asia. Now, I would like to also let you know that at the top right corner, and I will share my screen for you to see it. If you click on the event board button and then select the shared files, you will find the Dow COF stable resin brochure in English for you to download. So you're most welcome to download this material and follow up on it later. Now I would like to move for the short introduction of the COF stable resin.
In the flexible packaging industry, Maintaining a film COF at a stable level is an essential component to optimize performance and efficiency. However, keeping it stable is a challenge. COF changes during lamination, curing, storage and transportation, and hot weather. As a global technology leader in polyethylene, the scientists at Dow have found a solution with the new COF stable resin. We put our COF stable resin to a series of tests with other standard metallocene LLDPE. In our first experiment, PE and PET films were laminated using water-based and solventless adhesives. The COF of the standard film increased from 0.2 to more than 0.5, while the film made with the COF stable resin demonstrated less variation regardless of the adhesive used. In our second experiment, we wanted to find out the changes to COF in long-term storage and long-haul transportation. We simulated the conditions in our laboratory. After 11 months in the storage, COF of the film, made from our COF stable resin, remained almost at the same level, while that of the standard film has dramatically increased by more than 0.5. In our third experiment, we looked at the COF values of the PET surface and observed that it only dipped marginally after 4 weeks. We tested the runnability at the VFFS line in our fourth experiment. Unstable COF might result in film breakage and interruptions, which impacts the packaging efficiency. Our COF stable resin enables a faster and smoother production. Dow's new COF stable resin brings new solutions to partners across the industry chain, with increased choices of adhesive, simplified curing process during lamination, higher tolerance for tough storage and transportation conditions, improved packaging efficiency, reduced environmental footprint.
We have been in the business for years. One of the things we learned is the importance of listening to our customers. Your problems inspire us. We don't develop new products for the sake of having new products. We develop them for you. Our new coefficient of friction, or COF stable resin, is a prime example. This is an innovation created in Asia that we are very excited to talk about. We are consumed with transforming challenges into opportunities and helping you solve your problem one step at a time. It takes collaboration, curiosity, and the belief that the next breakthrough is only an inspiration away.
Be part of the innovation.
Now, I would like to invite you to answer a short question, which is, are you currently experiencing COF issues? This, of course, will help us, our experts, to provide you with more in-depth answer and to follow up later with appropriate information. So if you could please select one of the answers, and please remember to click the Submit Vote button at the bottom of the survey. I see that almost half of you have answered. Thank you very much. I hope that the remaining few people will join and quickly provide their answers. Okay, we will be ending the poll in 10 seconds. So if you would like to participate and cast your vote, please do it now. Thank you very much. And now let's move on to the presentation for which all of you are joined us here.
Thank you, Timothy, for the introduction. A very good day to everyone on the line. Thank you for calling in to our webinar today. My name is Eng Mei Yan. In the next 20 minutes, I will be sharing with you about Dow's new COF stable resin XUS 59999.110. We'll first look at the market trends to drive innovation in the flexible packaging industry, followed by an overview about COF, where we'll discuss the importance of COF and some issues faced by users in the flexible packaging industry. Next, I will introduce Dow's new grade that was developed to help resolve COF issues. And then, I will share the evaluation and results of the experimental work that was performed on this new grade by the Dow team in the Dow laboratory. Lastly, we will conclude all the information that is shared in this presentation. Let us first look at the mega trends of flexible packaging. Why are the mega trends important? Well, packaging and consumer goods companies are constantly looking to innovate and develop packaging solutions to stay ahead of competition. By analyzing the mega trends, we are putting the consumers at the heart of the business. Successfully identifying, analyzing and acting on mega trends is essential for success in consumer markets to gain market share and expand consumer base. Particularly in societies with a high rate of development and urbanization, consumers with on-the-go lifestyle are more willing to spend money on products or services that save them time, and they could stand to benefit from products that are convenient to use. To save the time from going to the physical stores, more and more consumers are purchasing online. E-commerce retailing has gained much further traction with the recent COVID-19 pandemic. It also enables new shopping behaviors, allowing consumers to deal directly with other consumers, compare prices, and get the best deal at the touch of a button. With urbanization, a larger section of the population is entering the middle class category. Many of the modern working city professionals dine alone, require fast, easy to prepare products, and often care about nutritional content. Single-serve and portion control packages appeal to these consumers who are mindful over snacking, portion control, and sugar intake. With growing disposable incomes, this group of city dwellers have more spending power and are more willing to pay a premium for quality products which can meet their lifestyles and give them convenience. Modernization brings improved healthcare systems, and more people are growing beyond the age of 60, 70, or even 80. Living alone in later life is a part of the process of population aging. For the aging population and single-person households, smaller pack sizes are preferred, as these products take up less shelf space and reduce waste. The products will also need to be made easier to open for the elderly people. Consumers nowadays prioritize health, happiness, and simplicity and will spend more to get it. Flexible packaging has become a popular packaging choice for a range of reasons, including its versatility, durability, and lightweighting. It increases the shelf life of both processed and fresh foods and has significantly contributed to the reduction of food waste globally. Consumers are becoming increasingly sensitive to issues of plastic waste, and this is impacting their shopping habits. Single-use packaging and microplastics are coming under increased scrutiny. The proportion of those who are willing to pay more for packaged food and fresh food, which is environmentally conscious or eco-friendly, has risen over the past few years. Similarly, the proportion of those who feel that recyclable packaging is an influential feature in products has also grown. We can take the first step to create recyclable packaging to spearhead the recycling trend. Volatile organic compounds, or VOCs, may be emitted from flexible packaging production processes such as printing, coating, laminating, and equipment cleaning, resulting in air pollution. VOC emissions can be greatly reduced by adopting more eco-friendly solutions and products, such as switching from solvent-based to water-based and solvent-free laminating adhesives where possible. The new packaging machines of today are running at much higher speeds and efficiency than before. New innovations in both machinery and film structures are crucial to meet this new demand. Dow is constantly innovating in the flexible packaging arena, especially with our latest COF stable resin XUS 59999.110, which is a new sealant resin to tackle unstable COF issues. How can we accelerate packaging innovation to market? We love to collaborate, and we have been doing it for a long time. Dow works with all members in the packaging value chain, including brand owners, film manufacturers and converters, equipment manufacturers, and packaging designers, to collaborate, innovate, and accelerate new projects and developments. Coupled with Pack Studios, Dow's global service network of packaging experts, equipment and testing capabilities, the result is faster commercialization of new and improved packaging. Let us understand more about COF. Coefficient of friction, or COF, is important for film converting. It is an important property of all materials which run on high-speed film converting and packaging lines. Flexible packaging can be done on vertical and horizontal form fill seal machines, in which a roll of film or laminate comes into contact with itself or other metallic and non-metallic components of the form fill seal machines. This contact generates friction, which can inhibit the material to run properly on the machines and achieve desired production rates. Controlling COF gives processors the ability to optimize performance and avoid problems in forming, transportation, and storage of packaging materials. The COF of a packaging product needs to meet the qualifying specification and be maintained to be consistent. It is very common that slip additives are used to reduce the COF of a polyethylene sealant film during critical production phases, which helps to decrease the film's tendency to stick to the various working parts of the machine. However, there are cases where the COF initially achieved does not remain consistent. The COF value of a packaging film has been observed to vary. One possible reason is that the slip additive may migrate inwards towards the adhesive that has high surface energy, especially with the use of solvent-free adhesives. This phenomenon of COF variation may not be observed immediately after the laminate is produced. The result is unstable COF or poor runnability on converting and packaging machines. The COF of a packaging film or laminate may vary as it undergoes various processes, such as during adhesive lamination, especially with the use of solventless adhesive with high temperature curing and surface treatment. The COF may also vary after the film roll undergoes storage in the warehouse or transportation after some time. The COF variation may be accelerated by high ambient temperatures, which could be weather dependent, and this is beyond the control of the converter. So next, let us look at how to resolve this issue. To help to resolve the issues faced by many customers in controlling COF of their packaging film and products, Dow has developed the new COF stable resin XUS 59999.110, which has a melt index of 1.0 and a specific density of 0.918. This product is designed to be used as a sealant resin. It aims to help you to achieve stable and low COF after lamination and curing. It enables you the flexibility to use a wide range of laminating adhesives. The COF of your film product will be stable even if it needs to go through long time storage or transportation, and even if it meets a high ambient temperature environment. In addition, it has minimal effect on the optical properties, heat seal properties, and bond strength. Most of all, with this drop-in solution, you will not need to formulate slip additives for your polyethylene sealant resin anymore. In the following slides, we may be referring to this product as a COF stable resin XUS 0.110. The performance of the new COF stable resin XUS 0.110 was demonstrated in the evaluation performed in the Dow laboratory. In this experiment, the 3-layer co-extruded polyethylene blown film was produced on the extrusion blown film equipment. This 50 microns polyethylene film was laminated with 12 microns of PET film. The laminate film roll was cured at 50 degrees Celsius for 48 hours in the oven. The COF and other physical properties like bond strength and seal strength were measured after the roll was removed from the curing chamber. The optical properties of the polyethylene film was also measured. The evaluation compared two sealant formulations. The first formulation uses the traditional metallocene LLDPE resin, and the second formulation uses the COF stable resin XUS 0.110. A graph on the left-hand side shows the COF of the polyethylene film before lamination and the COF of the laminate after lamination and curing. The lamination was performed using both solventless adhesive and water-based adhesive. The results show that before lamination, the COF of the polyethylene film for both sealant formulations was about 0.2. After lamination and curing, the COF of the traditional metallocene LLDPE sealant increased to above 0.5. While for the formulation with the COF stable resin XUS 0.110, the COF was maintained at 0.3 and below. This shows that the COF stable resin XUS 0.110 can help to maintain low and stable COF after lamination and curing. The graph on the right-hand side shows the bond strength of the laminated film after lamination using both solventless adhesive and water-based adhesive. The results show that the bond strength achieved with both traditional metallocene LLDPE resin and with the COF stable resin XUS 0.110 are very similar. This shows that by replacing the traditional metallocene LLDPE sealant resin with the new COF stable resin XUS 0.110, it does not affect the lamination bond strength. Next, the COF of the polyethylene film rolls and the lamination film rolls were evaluated after long periods of storage. The graph on the left-hand side shows the COF of the polyethylene film after the rolls were stored at 60 degrees Celsius for up to 7 days. With the traditional metallocene LLDPE sealant, the COF increased to close to 0.4 after storage. While with the COF stable resin XUS 0.110, the COF was maintained below 0.3. The graph on the right-hand side shows the COF of the lamination film with solventless adhesive after storage for 24 hours and 11 months at room temperature. With the traditional metallocene LLDPE sealant, the COF increased to 0.5 after 24 hours of storage and to above 0.7 after 11 months. While with the COF stable resin XUS 0.110, the COF was maintained below 0.3. This demonstrates that the COF stable resin XUS 0.110 can help to maintain low and stable COF of the packaging film even if it needs to go through long time storage or transportation. Another benefit that was observed with the use of the COF stable resin XUS 0.110 is that it can also help to maintain stable COF on the outer PET surface. In this experiment, the COF of the outer PET surface was measured after up to 1 month of storage. It was observed that the COF of the outer PET surface decreased with long-term storage. This could be due to the migration of the slip additive from the PE sealant surface to the outer PET surface as they contact each other in the winded roll. The results show that compared with the metallocene LLDPE sealant, using the COF stable resin XUS 0.110 will give a smaller decrease in the COF of the outer PET surface. For the roll stored for 1 month, the film sample was collected at different positions of the film roll: outer, middle, and inner. It was found that with the metallocene LLDPE sealant, the COF of the outer PET surface decreased to below 0.1 at the middle and inner positions of the roll after 1 month of storage, while with the COF stable resin XUS 0.110, the COF was maintained around 0.25 at the same positions. with the more stable COF of the outer PT surface achieved with the COF stable resin XUS 0.110, it can help to improve the runnability of the film on the automated packaging machines and increase productivity. Here, the optical and heat seal properties of the film were also measured. The graph on the left-hand side compares the haze and clarity of the polyethylene films using both formulations with the traditional metallocene LLDPE sealant and the COF stable resin XUS 0.110. The results show that the haze and clarity of both polyethylene films are very similar. The graph on the right-hand side shows the heat seal strengths of both the lamination films using both traditional metallocene LLDPE sealant and the COF stable resin XUS 0.110. These results also show that the heat seal strength of both laminate films are very similar. Therefore, by switching from the traditional metallocene LLDPE sealant to the COF stable resin XUS 0.110, there is minimal or no impact on the haze and clarity of the polyethylene film and the heat seal strength of the laminate film. In conclusion, COF is a very important property for flexible packaging, especially when it is used in high-speed automated packaging processes. However, the COF of a film may vary along with different processes, transportation, and storage conditions. The unstable COF is not favorable for achieving packaging productivity and may have a negative impact on it. With the new COF stable resin XUS 59999.110, you can have more choices of laminating adhesives. The curing process during lamination can be simplified, as a COF initially achieved can be maintained even when higher curing temperatures and corresponding shorter curing times are used. The packaging film produced will be able to tolerate tough storage and transportation conditions, such as high ambient temperatures and storage for long periods of time. The consistently maintained COF will help with packaging efficiency when running on high-speed automatic form-fill seal machines. With the flexibility to use solventless adhesive, it can also support to reduce the environmental footprint with lower VOC emissions. With this, I have come to the end of this presentation and will hand it over to Jason. Thank you.
Hello, everybody. Thank you, Ms. N. Mei Yen, for this informative presentation. I see that we already have quite a few questions. I would like to remind everybody that we will have now about 25 minutes for an open forum. So please don't be afraid to ask even more questions. I would like to ask Ms. N. Mei Yen and Ms. Anil Yao to join us now again and start answering those questions. So let's begin with the first.
Hi, so the question is XUS 59999.110 a metallocene PE? So Annie, can you take this question? Oh, okay. So I think Eddie is not able to unmute himself. But this is our
Sorry, I would just like to interject. Miss Annie forgot to turn on her microphone, I think, during your presentation, but I see it's on now. So, Miss Annie, if you could take this question. Hello? It seems that Miss Annie.
Can you hear me?
Oh, yes. Yes. If we can hear you now.
Yeah, this stable CO resin XUS 0.110 is also a metallocene PE.
thank you, Annie. So so this is a metallocene PE resin. Yes. So we are a CPP film producer. Can we use this X 59999.110 in the sealing layer? So Annie, can you take this question too?
If you want to use this resin in the sealant layer of a CPP film, there will be some issues you have to consider. The first one is the processability. Because this 0.110, the MI is quite a bit low, so the processability in a casting PP line is not so good. You have to lower down your line speed. And secondly, between the PE, because this is a PE, between PE and PP, you have to add ad- adhesive layer to bond the PP layer with this PE layer. So we would not suggest to use this resin in a CPP due to those problems.
Yes, thank you, Annie. So the next question is additional slip agent needed if using the stable COF resin? So additional slip agent is not required if you use the stable COF resin. Can COF neutrality be maintained by using XUS 59999.110 in high temperature storage, as some countries could be very hot during the summer period? So in our laboratory evaluation, we have found that for the storage, I think in one of the slides we did show some data. So with our XUS 0.110, the COF can be maintained to be more stable, to be more neutral compared to the traditional metallocene PE resin. So if you have situation where you need to store materials at high temperatures, such as during summer, so this resin could be able to help. Can you please share the COF stable at different position of the roll, outside of roll versus inside of the roll? So in our slide, we showed that the COF, I believe this is referring to the COF on the PE side in the roll. Outside of the roll versus is okay. So in one of the slides we showed the PET surface COF that varies from inside to outside the roll, but for the PE side it will not vary. Do you have longer term data for this grade, such as more than 1 year? Yes, we have done more than 1 year of study. We have stored the film roll in our laboratory for more than 1 year. And we found that the film with XUS 0.110, the sealant, the COF can be maintained at around 0.25, that is below 0.3. But for the film without XUS 0.110, the COF increased to more than 0.7 and becomes sticky also. Yes. So if you need more information on longer term storage, you need more information on data, you can reach out to our TSNDs. After curing, how long do you leave the laminating film before COF measurement? So usually we would test it 1 day later, that means 24 hours later. It will need a little bit of time for the COF to take effect or to be stable, to achieve the COF required. So therefore, usually we'll test it a day later. Is there any test data of polyamide laminated with LLDPE? This question is because there is a moisture sensitivity of the polyamide. So Annie, can you take this question if we have any data on this?
Yes, for the BOPA lamination structure with the PE film, due to the polarity of the nylon outside and also is sensitive to moisture, um, the COF will decrease after long-term storage of the lamination film. But by using the XUS 0.110 compared with traditional metallocene PE film, it still shows the advantage to maintain the COF. Also, it also decreased, but compared with other types of the metallocene LLDP film, this XUS 0.110 still can have better performance.
Do you have any comparison analysis data with conventional metallocene LLDPE for dart drop values? Annie, can you take this question too?
For this one, you have to consider the overall film structure. So I would like to say, if to apple comparison, for example, we just use this XUS 0.110 to replace the sealant layer, the 918 density metallocene, the dart test value is the same compared with the same density sealant layer. Yeah.
Can you tailor the final COF of the laminated film? Tailor okay. So you can so how do we use the COF stable resin is as a sealant in the PE film layer. So you will want to first understand what level of COF do you want to achieve on the PE sealant surface, and and depending also on the thickness of the film, then you will formulate the COF sealant resin into your film. So in terms of tailor, I'm not too sure what level of COF you're looking to achieve right here. So perhaps for this question, if you have a specific project in mind and a specific COF that you want to maintain for your formulation, you can reach out to our technical persons, technical service, and then we can address this directly and more accurately with the information. So what is the difference between XUS 0.110 and Dow Elite AT 6101, 6202, and Dow 1881G? So Annie, can you take this question?
Okay. If we look at these different types of sealant layer, there's a density different. So for our Elite AT like 6202 or our Affinity 1881, for those two materials, they are designed for low HSIT, low heat sealing initial temperature applications. And if you are requiring a much lower HSIT, heat seal initial temperature, you have to use these two grades instead of XUS 0.110. For 0.110, due to the higher density at 918, the sealing initial temperature will not be as low as those two grades. Or you can consider to combine XUS 0.110 with some this kind of low HSIT resins. And for Elite AT 6101, this is special designed for stretch hood application without any slip agent and anti-block inside. For the other three, we have slip agent and anti-block inside.
Is pellet size influence on COF during feeding on high-speed lamination? For this question, I'm not too sure what does the pellet size refer to. I am assuming that it refers to the polyethylene pellet size, That could be one. And the other possibility is that it could be referring to the content that is put into the package, the pallet size. So for the, if you're referring to the PE pallet size, it will not have influence on the coefficient of friction. So I'm sorry, because I'm not too sure of the definition of pallet size. If you don't mind, you can retype your question again and we will come to it again. Thank you. Do I need to adjust XUS 0.110 ratio according to the film thickness? So Annie, do you mind taking this?
Yes. For the film structure and also the film thickness will have an influence on the final COF of the film. So you have to consider your total thickness and also your layer ratio of the COXP film to adjust the ratio of the XUS 0.110 in the sealant layer. Just for example, if you have a film with 15 micron thickness and the layer ratio is about 3:3 layer ratio, and for this kind of film, you have to add 50% of XUS 0.110 into the sealant layer to ensure the stable and low COF. But if you have a much thicker film, for example, for 70 or 80 or even 100 micron, then you can decrease the loading ratio into the sealant layer. Or if you have a very thin film, like only 30 to 40 micron, then you have to increase loading of XUS 0.110 into the sealant layer. And also for a thinner sealant layer, for example, also a 50 micron P film, but if your layer ratio is 1:1, which means you have a much thinner sealant layer, you also need to consider to increase the loading ratio of XUS 0.110 in the sealant layer. So I would suggest you to contact your TSND, Dows TSND, and for some detailed structure to have a discussion on the final film structure recommendation.
Have you developed any COF stable resin for CPP yet? So right now we only have one COF stable resin product, which is XUS 5999.110. So that will be our only product for now. Is it have higher film odor than barefoot film? So have we done any odor tests on this resin film?
We didn't have the data, lab data, but we already sold about 1,000 metric ton materials into the market. We didn't hear any feedback, negative feedback about these resins or the issues. So we should say that this resin have the same performance as the traditional metallocene or the traditional PE resins.
Is a film made with this material able to be tested straight off the blown film line to have stable result right away? So what we usually do is we would test it about 24 hours after it leaves the extrusion blown film line. It will take a bit of time for the COF to be achieved, and therefore we would recommend to test at about a day after it is produced. It will be more accurate. It's more stable. Compared with other solutions like adding additional slip agents or using different type of adhesive during lamination, what's the advantage of stable COF resin? So Annie, do you think can take this?
In the market, there are several different kind of solutions. Actually, control COF is a systematic work. No matter the film structure or the lamination process, all this will have effect on the final COF of the lamination film. So you can add additional slip agent to lower your COF, but there will bring other problem like the blooming if you add too much, and also adding too much slip agent in the sealant layer will cause the other side, like the PET side or nylon side, COF dropped a lot after lamination. That will be some problem in the downstream packaging line. And another solution is using different types of adhesive. Currently, there are polyester type or polyether type adhesive. But when you change different type of adhesive, this will also bring some other issues like different level of the bonding strength. So by using our stable COF resin, it will give you more tolerance to the different types adhesive. And also you don't have to consider to adding additional slip agent, which will cause other problem. This is a more convenient solution for you. Yeah.
In your testing, solventless adhesive is polyester or polyether. So in our testing, the solventless adhesive is a polyether-based adhesive. Is that just to confirm any? Do we do any polyester-based adhesive testing too?
For polyester type adhesive, normally it's not easily to absorb the slip agent from the sealant layer. So normally the customer will not have this kind of problem. But we do have data to support that for polyester type adhesive, the XUS 0.110's performance is also quite good. The reason we take a polyester type solventless adhesive is because the polyester type adhesive is more easily to absorb slip agent from the sealant layer, which will cause the COF change.
Can this resin be used in other layer of PE coax film? So if the PE coax film is laminated to a PET film or BOPA film to be used as a laminated film, we recommend that you only use it in the sealant layer. We do not recommend that you use it in other layers too. So it is only required to be used in the PE sealant layer. What is the density and melt index? So the density is 0.918 specific gravity and the melt index is 1.0. Can SUS 59999 be used in extrusion lamination process? So this one, maybe Annie can take out, very similar to the CPP question.
For this one, actually we don't suggest use this resin in the extrusion lamination process because the MI is too low. The processability will be not good.
Why does the decrease in the friction coefficient of PET film causes problems in the product? So when we refer to the COF or the PET film, we're referring to the outer surface of the PET film. So if the PET outer surface COF is too low or becomes too low, then there could be an issue of slippery film when it runs on your high-speed packaging machine. And it might be sliding side by side. The film will not run stably on the machine. Then it could affect your productivity. Then you may not be able to run at such a high speed. Can this COS stable resin be used for metallized PE film? So Annie, do you mind taking this too?
Can this COF stable resin be? You mean in the metallized P film in the sealant layer? Or which layer? Or this kind of metallized P film is a coax structure. So if you don't mind,
I think some people they produce PE film and they metallize it, and the PE could be a 3-layer coax film. So I think this asking if the sealant can be used in the sealant layer of the metallized PE film.
If it's 3-layer coax P film, no problem. But if it's just one single layer, since there is a slip agent and anti-block inside, there will cause problem. So if it's for the 3-layer coax PE film, you can use this stable COF resin in the sealant layer.
So COF stable resin can solve the blooming issue of slip also. So Annie, can you take this?
This resin is not designed to solve the blooming issue, but according to the current feedback from all the customer, we didn't hear any blooming issue by using this resin in the sealant layer.
What is the lowest COF value that you have achieved with XUS in the sealant layer? So as is shown in the presentation, the COF can go as low as 0.2. So, so Annie, do we achieve anything lower than 0.2 in our studies?
Depending on the film structure and loading of this XUS 0.110 in the sealant layer, normally if it's just for the pure P film, actually you can go to the COF of lower than 0.2 after the P film fabrication, and the lowest maybe is like 0.12 or 0.15, this kind of level for the P film. And then after lamination, there will be some increment, but also can be well controlled at 0.2. So for this question, actually is depending on the film structure and also the loading of the this resin in the sealant layer. You can adjust loading to achieve much lower COF. Yeah.
Is there any difference in any of the value of dart and seal strength comparing XUS with metallocene LLDPE? I think Annie has answered this partially just now. So if we are comparing XUS, which has a density of 0.918, with another metallocene LLDPE, which if it has the same density, then there should be no difference in the seal strength, and the dart impact, there should not be a big impact, the big difference too. Yeah. So we do not think that there will be a big difference if you are comparing metallocene PE with the same density. How long will it take for COF to stabilize in raw form after it undergoes high temperature storage? So Annie, can you take this?
Normally after the blown film, after like 24 hours, the COF will stabilized. But if the film are stored at high temperature, you can see the COF increased step by step. I think in the previous presentation, you also see that there's some internal aging experiment did in the lab to show that if you put the PE film rolls in the oven at 60 degrees C, you can see the COF for the traditional metallocene, the COF will increase step by step after like 7 days or even longer. The COF will keeping increasing. So for the high temperature storage, or if you want to measure the COF, also suggest that you test the COF at least after 4 hours to test the COF to compare the COF values. But if you still keep it into the high temperature, you can imagine the COF will still changing time by time.
If I would like to use this resin in a 5-layer blown film extruder, which layer that I have to add? So this resin is designed to be used as a sealant resin. So you add it in the sealant layer. When you say COF stable, does it mean that it reduces migration of movement of slip agent or otherwise, other else? COF stable, in this case, it controls the migration of the additive. So it controls it in a way that you will be able to achieve a COF stable. That means that you want to jump around, it will not move around very fast. So it controls the migration of the slip agent. Does this new resin have any advantage or disadvantage in terms of blooming on the film surface due to slip? So, Annie, do you mind taking this? I think quite similar to last one.
Yeah, I think this question is quite similar to the last one regarding the blooming issues. As I just mentioned, for the blooming issue, it had to be run in the industrial line for quite a long time. So in our lab, we cannot quantify this blooming issue quite well. But according to our previous experience of as we already sold out about 1,000 metric ton these resins from last year, and we didn't hear any negative feedback about this blooming issue, or we didn't hear any blooming issue from the customer. So we should say for this reason, it's fine to control the blooming.
Are the COF figures achievable with other solventless adhesive or only with more free? So this CO, because the COF figures are achievable with adhesive, solventless adhesive, which can be polyether based, because polyether based adhesive has much higher surface energy. So if you're using a polyether based adhesive, the COF will be able to achieve will be more stable with this resin. Do we have to use 100% dosage? What is the minimum blending ratio with other P materials in the sealant layer? So I think Annie, you can take this because I think someone answered previously also.
Yeah, I think for this question, it's depending on your detailed requirements on the COF and also your film structures. If you have a much thinner film or much thinner sealant layer, definitely you have go to higher dosage of XUS 0.110 into a sealant layer. But if you have a much thicker film and also much thicker sealant layer, you can adjust your dosage of XUS 0.110 to a little bit lower ratio. And another reminder is that for the other resins, if you are doing the blending in the sealant layer, for the other resins used in the sealant layer, you have to use the resins which already containing the slip agent.
Thank you very much for your time and for answering all those quite in-depth questions. Our experts today was Ms. Mei Yen, and he's Marketing Technical Manager for Southeast Asia, Australia, and New Zealand, and Ms. Annie Liao, the Technical Service and Development Scientist, North Asia. For all the attendees and for all the questions that haven't been answered yet, there will be collected and passed on to the Dow Chemicals representatives, and they will follow up on it accordingly. For the last thing, I would like to remind that you can still download the brochure at the right top corner. If you clicked on the event board and then shared files, you can still download the COF stable resin brochure in English. And with that notice, I would like to also direct you to, if you would like to ask more questions after the event, you can please note the email contact addresses for Mr. Jason Yu and Ms. Mei Yen. They're on the screen now. And I would like to thank you very much all for coming. And I hope that this webinar provided you with a lot of good information how to increase the efficiency of your manufacturing lines. Thank you very much all for coming, and that will be the end for this webinar today. Goodbye. After the finishing of this event, you will see a redirected page with a very short few questions, and we would very much appreciate if you could answer them to help us to improve our webinars and to provide more information about this webinar to Dow Chemicals as well. Thank you and goodbye.